have learnt in class 9 that during a chemical reaction atoms of one element do not change into those of another element. Nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and making of bonds between atoms to produce new substances. You will study about types of bonds formed between atoms in chapters 3 and 4. 1.2.1 Combination reaction. Figure 1.3 Formation of slaked lime by the reaction of calcium oxide with water. Activity 1.4. Take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Touch the beaker as shown in Fig. 1.3. Do you feel any change in temperature? Calcium oxide reacts vigorously with water to produce slaked lime, calcium hydroxide, releasing a large amount of heat. Cows plus quicklime. H2O, L, right pointing arrow Ca, O2, Aq plus heat. Slaked lime. 1.13. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as a combination reaction. Science. 6. Rationalize 2023-24. Do you know? A solution of slaked lime produced by the reaction 1.13 is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. It is interesting to note that the chemical formula for marble is also CaCO3. Calcium. CaO2, Aq, plus CO2, G, right pointing arrow CaCO3, S. Calcium hydroxide. Burning of coal. Carbonate. Plus H2O, L. Let us discuss some more examples of combination reactions. I. Cs plus O2, G, right pointing arrow CO2, G. E. Formation of water from H2, G, and O2, G, 2H2, G, plus O2, G, right pointing arrow to H2O, L. Per language we can say that when two or more substances, elements or compounds, combine to form a single product, the reactions are called combination reactions. In activity 1.4, we also observed that a large amount of heat is evolved. This makes the reaction mixture warm. Reactions in which heat is released along with the formation of products are called exothermic chemical reactions. Other examples of exothermic reactions are I. Burning of natural gas. CH4, G, plus 2O2, G, right pointing arrow CO2, G, plus 2H2O, G. E. Do you know that respiration is an exothermic process? We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction is respiration, the process of which you will study in chapter 6. C6H12O6, Aq, plus 6O2, Aq, right pointing arrow 6CO2, Aq, plus 6H2O, L, plus energy. Glucose. E. The decomposition of vegetable matter into compost is also an example of an exothermic reaction. Identify the type of the reaction taking place in activity 1.1, where heat is given out along with the formation of a single product. 1.14, 1.15, 1.17, 1.18. Chemical reactions and equations 7. Rationalize 2023-24. 1.2.2 Decomposition reaction. Figure 1.4 Correct way of heating the boiling tube containing crystals of ferrous sulfate and of smelling the odor. Activity 1.5. Take about 2 grams ferrous sulfate crystals in a dry boiling tube. Note the color of the ferrous sulfate crystals. Heat the boiling tube over the flame of a burner or spirit lamp as shown in Fig. 1.4. Observe the color of the crystals after heating. Have you noticed that the green color of the ferrous sulfate crystals has changed? You can also smell the characteristic odor of burning sulfur. 2FeSO4S. Heat. Right pointing arrow. Ferrous sulfate. Fe2O3S plus SO2, G plus SO3, G. Ferric oxide. 1.19. In this reaction you can observe that a single reactant breaks down to give simpler products. This is a decomposition reaction. Ferrous sulfate crystals, FeSO4, 7H2O, lose water when heated and the color of the crystals changes. It then decomposes to ferric oxide, Fe2O3, sulfur dioxide, SO2, and sulfur trioxide, SO3. Ferric oxide is a solid, while SO2 and SO3 are gases. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. It has many uses. One is in the manufacture of cement. When a decomposition reaction is carried out by heating, it is called thermal decomposition. Cu3S. Limestone. Heat. Right pointing arrow. Cous plus CO2, G. Quicklime. 1.20. Another example of a thermal decomposition reaction is given in Activity 1.6. Activity 1.6. Figure 1.5 Heating of lead nitrate and emission of nitrogen dioxide. Take about 2 grams lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame, as shown in Fig. 1.5. What do you observe? Note down the change, if any. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide. Number 2. The reaction that takes place is Science 8. Rationalized 2023-24. 2 petabits. Number 3. 2. S. Heat. Right pointing arrow. Lead nitrate. 2 PBOS or NO2, G plus O2 grams. Nitrogen dioxide. Oxygen. 1.21. Let us perform some more decomposition reactions as given in Activities 1.7 and 1.8. Activity 1.7. Take a plastic mug. Drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers as shown in Fig. 1.6. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. Is the volume of the gas collected the same in both the test tubes? Once the test tubes are filled with the respective gases, remove them carefully. Test these gases one by one by bringing a burning candle close to the mouth of the test tubes. Caution: this step must be performed carefully by the teacher. What happens in each case? Which gas is present in each test tube? Activity 1.8. Take about 2 grams silver chloride in a china dish. What is its color? Place this china dish in sunlight for some time. Fig. 1.7. Observe the color of the silver chloride after some time. Figure 1.6 Electrolysis of water. You will see that white silver chloride turns gray in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. 2 AgCls. Sunlight. Right pointing arrow. 2 Ags plus Cl 2 grams. 1.22. Figure 1.7 Silver chloride turns gray in sunlight to form silver metal. Chemical reactions and equations 9. Rationalized 2023-24. Silver bromide also behaves in the same way. 2 AgBr sunlight. Right pointing arrow. 2 Ags plus bridge 2 grams. 1.23. The above reactions are used in black and white photography. What form of energy is causing these decomposition reactions? We have seen that the decomposition reactions require energy either in the form of heat, light or electricity for breaking down the reactants. Reactions in which energy is absorbed are known as endothermic reactions. Carry out the following activity. Take about 2 grams barium hydroxide in a test tube. Add 1 gram of ammonium chloride and mix with the help of a glass rod. Touch the bottom of the test tube with your palm. What do you feel? Is this an exothermic or endothermic reaction? Questions 1. 2. A solution of a substance, X, is used for whitewashing. I. Name the substance, X, and write its formula. E. Write the reaction of the substance, X, named in I, above with water. Why is the amount of gas collected in one of the test tubes in activity 1.7 double of the amount collected in the other? Name this gas.